Welcome to tutorial 3.7 part 1. This is the first of 3 tutorials on limiting reactants. These problems tend to cause a few problems for some students, so I've kind of set up this system here where I think it's going to help you kind of keep track, kind of do the bookkeeping. And if we follow this system, I think you're going to see that it's okay. So what are these questions about? They're always about the same thing. You have two or however many reactants given, and you have too much of one of the reactants. You can't react all of that material. You have it in excess. The other reactant, the one that you have enough of that you can react it all, is going to limit. It's the limiting reactant. It's going to limit how much product that we can make. It's best just to look at this as an example. So let's look at this first example. Imagine someone had in a box 1, 2, 3, 4 hydrogen molecules and 4 oxygens. And the question is, how much water can you make? First, let's just write down what we have in terms of molecules. We have 4 hydrogens and 4 water. And the next thing, a nice systematic way to do it, just go ahead and assume that you can use up all of the first reactant. Not sure that you can, but go ahead and assume if you can. So write down the 4 under what you can use. Imagine you can use them, and then look at the balanced equation. For every 2 hydrogens, you need half as many oxygens, so you need 2. And the question then is, look at the other box. Do you have the 2? Oh, actually you do. You've got 4. You have an excess of oxygen. So you can use up 2 of the 2 oxygens, and therefore you're going to make, following the 1-to-1 ratio, 4 water molecules. So what do you have left over in the box when you're all done? Well, you had 4 hydrogens, used them all up. We don't have any. Of the 4 oxygens, you only used up 2, so there's still going to be 2 left over. There were no waters to begin with, so whatever we make on the right-hand side is what we end up with. Now stop and look at this for a minute and see if this really kind of makes sense. It should. To make water, I need to have 1 oxygen and 2 hydrogens, 1 at either side of the oxygen. So if you look at this, you're going to say this is going to be enough stuff to make 1. Here's the second, third, 4 water molecules is all I can make. And I'm going to use these 2 oxygens and then those 2 to get those 4 waters made. These 2 molecules of oxygen are not going to react. They're not going to find any hydrogen to react with. So this is the answer. What do we have left over when we're done? No hydrogen, 2 oxygens, and a water molecule. Let's try another one. We'll just kind of click on this thing and see what they give us. Same equation, but different numbers. Let's go through it again. How many hydrogens do we have? 2, 4, 6, 8. How many oxygens do we have? 4, 5, 6. And again, just kind of mechanically, just go through the process and say, okay, let's assume I can react all 8 of these hydrogens. What's the ratio? For every 2, I need 1. Half of 8 is 4. Hey, great, I have that much. I actually have 6. So how much water am I going to make? 1-to-1 ratio. I'm going to be able to make 8 waters. When I'm done, what's going to be left? 8 minus 8 is 0. 6 were a present of oxygen. I only used 4 of them, so I have 2 of them left over. And finally, how many waters can I make? I'm going to end up making 8 of them. So hopefully that made sense, and let's just double check if that would say, oh great, we got them all correct. Let's just try, well, this gave us the same one, so let's refresh the page and get a different question. So let's look at this one here. Aluminum and oxygen makes aluminum oxide. So what do we have this time? So there's no pairs or no molecules here. Just count the atoms, 1, 2, 3, 4, 5, so we have 8 of them. And how many oxygen molecules do we have? 3 molecules. So let's go ahead and try to use all 8. We say, okay, for every 8 aluminums we have, for every 4 aluminums we need 3 oxygens. For every 8 we would need 6. So this time we say, oh, well, wait a minute, that doesn't work out. If you need 6 oxygen molecules, we don't have it. We only have 3. So you can't actually use all 8 aluminums. So we're going to say, oh, backtrack, can't do that. So we're going to erase these and say, okay, if we can't use all those 8 aluminums, that means we can use the 3 oxygens. If we use the 3 oxygens following the 4-to-3 ratio, only 4 aluminums are going to be used up. So what will we make? Following the ratio, for every 4 we make half as many of these, or just 2. Just follows the exact balanced equation itself. When we're all done, what's left? 8 minus 4 is equal to 4. There are no oxygens left. They were the limiting reactant. And how much were we able to make of aluminum oxide? We were able to make 2 units of aluminum oxide. And again, hopefully that made sense. Only 4 out of these 8 got used up because I need 2 aluminums for every 3 oxygens. So these 2 are going to require those 3 oxygens, for example. The next 2 say those 3. I'm all out of oxygen. I don't have any more, so therefore I can't react the other 4 aluminums down here. All right, so we say that one is good. I'd like to find a different ratio. Let me just kind of refresh this page and see if we can get a different reaction besides water. Let's see if I can get another one just randomly. Yeah, look at this one. Nitrogen and hydrogen are going to react. Same exact process. I have 1 nitrogen here, so I just have 1. How many hydrogens? I see 4. And I think you can probably tell pretty quickly what's going to happen with this one. You have too much hydrogen. You need 3 for every nitrogen, not 4. So what will we be able to use? You'll be able to use this one, and of the 4 present, you can only use 3, following the 1:3 ratio. How much ammonia do you make? 2 for every nitrogen. When you're done, what's left over? We don't have any nitrogen. Now we have 1 hydrogen left over, and we end up making 2 ammonias. And we check that and say, yeah, that's good. That's right. So I think this is probably good enough as a nice first shot at this. Practice these online like this, and the quiz you'll see is just like that. And then in part 2, what we'll do is we'll get away from the pictures, so we're not just looking at the pictures for it to make sense, but just the equations by themselves, and then do basically the same thing. All right, I hope that works out. We'll practice again in class. Thanks, bye.